Welcome, and today we are going to be learning about different nuclear reactions. Super easy, probably one of the easiest things. You'll just need a calculator and a little bit of memorization. So there are a few types of radiation that you're going to need to know. One is the alpha particle, and if you look at the alpha particle right here, it is the composition is the helium nucleus. How I remember that alpha is the helium is it has this H. It's the only one with an H in alpha, and out of all the different types of radiation, so I always think H for helium. And if you look at the symbol, first if you know your Greek letters, here's the alpha particle, but unlike me, you guys probably don't know the alpha symbol, so you would just need to know that if it's a helium nucleus, well, it's got the helium symbol, that number on top represents its mass, and that bottom number actually for these particles represents the charge. So because it's the helium nucleus, it is made up of 2 protons and 2 neutrons, so that's where it gets its mass of 4, and it gets its 2 protons, which gives it the atomic number, what you would think of it as the atomic number, but that's actually the charge of 2. So when you look at this, it's got a +2. And then how you can look at the example is you just basically try to find one of these particles in a formula, and here's your alpha particle. So this would be an alpha radiation reaction. Another type of radiation is your beta. And beta is the only one with an E in it. So what does it remind you of? That's right, it's an electron. A beta is an electron. So if you think about it, the beta particle, what is an electron? If this top number represents the mass and the bottom number represents the charge, well, what's the mass of an electron? Well, it's 0. What's the charge of an electron? -1. What's the symbol for an electron? Well, that's not very hard. It would be E. Beta particle is also the beta letter, so it looks like that. True story, when I went to college, a lot of people join Greek sororities or they enter their Greek life. Instead of actually knowing what these fraternities or sororities were, I actually tried to figure out chemical equations that I knew with these symbols in them. So a different thing is when you look at, I guess, a beta particle in a formula. So once again, you want to look at these different equations, or different pieces of the equation, and you look for one of your types of radiation, and here's your beta particle. So this would be a beta reaction of some sort. There are 3 more that you're going to have to memorize. So there are basically a total of 5. So you have a positron emission. A positron, if you look at the word, it is a positive, and then tron, I always think of the electron. So what is a positron? Well, it's basically a positive electron. Whoops, sorry, I didn't mean to cross that out. What would make up a positive electron? Well, if you're trying to think of the mass, which would be on top, the mass of an electron is 0. The charge of a positive electron would be the opposite of an electron, so it would be a +1, and the symbol would still be that E. What would the charge be? Well, looking at this guy, it says it's a +1, so that's where you get that. Gamma is basically high energy radiation. How I remember this is it's AA, MM, and OO, meaning that it has a 0 mass and a 0 charge. All it is basically lots and lots and lots and lots and lots of energy. This is the one that's extremely dangerous to us. So how I remember, once again, I have an alpha particle. You look at it, alpha particle has that H, so it is the helium nucleus. If you look at a beta has that E, it's the only one with the E, so it would be an electron. If you look at positron, if you break down the word, positive electron. So figure out what the symbol for a positive electron would be. And gamma is AA, M, so it's OO, meaning 0 mass, 0 charge, and it's this kind of like upside down fish type of thing. When you're trying to identify it in the particles or in a formula, you once again can look for a beta particle, or this would not be a beta, that would be a positron, and then you also see that gamma right there. The last particle is a neutron. A neutron, what is a neutron? Well, a neutron is a neutron. So what is a neutron? What's its mass? It'd be a 1. What's its charge? That would be a 0. And what would its symbol be? Logically, it makes sense. That would be N. I do want to reiterate that when you were talking about the alpha part, or when you were talking about nuclear particles, this number up here, okay, represents the mass. Exact same thing as when you're talking about an atomic symbol. This one down here represents the charge. This is the difference. Instead of the number of protons, it's the charge, and then this is just the normal symbol. Sorry, my handwriting's so bad. Okay, this is a very important graph or chart that you guys want to look at and be able to interpret. So if you look at this, you see the alpha particle, okay, which is here. You see the beta particle, and you see the gamma. So which one has the most penetrating power? Penetrating means to be able to break through. So which one is able to break through the most? That would obviously be the gamma particle right here, which is stopped by, actually, in real life, it's stopped by a few centimeters of lead or a few meters of concrete. On the other hand, if you have an alpha particle can be stopped by a piece of paper. Which makes sense. If you look at the masses of these things, which one would be harder to break through? The alpha particle is so freaking big that it's going to be stopped by a piece of paper, whereas gamma is so itty bitty, it can get in little bitty spaces. So that's why it can be stopped only by a few centimeters of lead or a few meters of actual concrete. Okay, another question. Which particle would the positron most be like? Well, the positron has a similar mass to what? And it's basically what? Well, if you think about it, it's basically the beta particle, which is your electron. Why? Because it's once again a positive electron. So which one it most be like? It would most likely be similar to having the same type of flight as your beta particle. So it probably would be stopped by a piece of wood, or if you're looking at this, a piece of plastic or your hand. Which stops a beta particle? Well, we just answered that because it's the same thing as a positron. So you could either say plastic, your hand, or a piece of wood, depending on which chart you were looking at. Okay, flight with magnets. This makes sense when you look at why the beta particle, which if you think about what a beta particle is, remember it has that E, so therefore it is an electron. What's an electron's charge? Negative. So what would it be attracted to? The positive. So it makes sense that a beta particle would be attracted to the positive. If you look at the alpha, what is the alpha particle? The alpha is the helium nucleus. Remember, if it's the helium nucleus, it has 2 protons, so it has a positive 2 charge. So what would it be attracted to? It's right in a negative. And then you have gamma, which is double A, double M, double O. So what would it be attracted to? Well, it doesn't have a charge at all if you look at its symbol. So therefore, it's not going to be affected at all by that positive or that negative field. All right, you are also going to be having to know some vocab, and it is as easy as A, B, C. When you are dealing with a type of reaction, and we'll be going over this more in class, but when you are dealing with a type of nuclear reaction, we often use terms called absorb, bombard, capture, decay, or emit. If you remember your A, B, C, and D, E, you will know which side that particle is found. If we were to say a beta, decay, typically it's emission, but we'll go with decay right now. What you are saying is that the beta particle is found on the, well, it's decaying, so therefore it would be the right side of the equation. Okay, so decay would be on the right side. I could easily just have said beta emission, and that too would be on the right-hand side. For all cases and purposes in this class, it really doesn't matter. You can use whichever one you want. You just have to be able to identify them. So if we use the terms absorb, bombard, or capture, those particles would be on the left-hand side of the arrow. Decay or emit is on the right-hand side. So now we're going to actually do some practice nuclear equations. This is as easy as using your calculator in addition subtraction. If you want to think of it as, for this one equation right here, if you want to look at it, basically what's going to happen is everything on the left has to equal everything on the right. And that's due to the massive conservation of matter and mass, meaning everything that you start with, you have to end with. You cannot create nor destroy matter. So what you need to do is think of it as 2 separate equations. You're going to make sure that the top balances and the bottom balances. So I'm going to re-equate it, and think of an arrow as an equal sign mathematically. So if we look at the top, we need to figure out what goes in here. So if you figure it out, it's 242. Instead of an arrow, I'm going to do it as an equal sign. 4 plus, and now I need to figure out this blank right here. So what number plus 4 equals 242? So that would be 238. Now I need to do the bottom. Okay, so I'm going to do 94 equals 2 plus, once again, I need to figure out this guy. So what number plus 2 equals 94? So that would be simple math, and that's a 92. So when I fill this in, it would be 238. So whatever it is has a mass of 238. It has an atomic number of 92. So all I need to do now is look at my periodic table, look for something that has an atomic number of 92, and that would be U. Now to do the bottom one, or the next one. Okay, so once again, we're just solving for this guy, okay, because that's the blank. So it doesn't matter which side as long as you're just looking at the blank. So what number equals 32 plus 0? So 32 plus 0 is equal to 32. So now I know that my top number is 32. When I do the bottom, 16 plus negative 1. Now remember, 16 plus a negative 1 is actually 16 minus 1, so that would be equal to 15. So 15 will go on the bottom. Once again, I'm going to look at the atomic number of 15, and I get P. Doing the next problem, this is a little bit trickier. Okay, why? Because we have this guy right here. Okay, so we have our unknown. We have one thing else on the left, and we have 2 on the right. Normally this wouldn't throw us off, but we have this 3 right here, so I'll teach you how to do it. It's just a simple little trick. So when we're looking at this, we're going to do 252 plus, what happened? Sorry, 252 plus x equals, this is going to distribute just like in algebra where if you had 3x, that would distribute to, or 3 and then x plus 1, that 3 would distribute to all the particles. That's saying I have 3 neutrons. So 1 neutron, 2 neutrons, and 3 neutrons. So if I had 3 neutrons, what would its mass be? Well, it would be a mass of 3 plus 259. So I solve for that, and I get 252 plus x equals 262. So my x equals 10. So I know my mass is 10. Solving for the bottom, I have 98 plus x equals 3 times 0. So that would be 0 plus 103. So solving for x, x equals 5. So what has an atomic number of 5? That would be boron. I'm going to do the final one with you. Okay, number 4. If you look at that, you're going to have 55 plus a number equals 55. It's 55 plus equals 55. So what number plus 55 equals 55? That would be 0. Then you do the bottom, 26 plus some number equals 25. So looking at that, wow, that looks messy. Sorry about that. X equals negative 1. So whenever you get a thing with a 0, either a mass of 0 or a charge of 0, you have to go to your nuclear particles. Well, what has a mass of 0 and a negative 1 charge? That would be your beta particle, so you just put in the symbol for beta. Once again, anytime you see a 0 and a negative, or a 0, then go back to your nuclear particles that you have to have memorized. Okay, and the last one, super easy. 15 equals what number plus 0? So that would be 15. And on the bottom, it's 8 equals what number plus 1? So that would be 7. So if you look at that, that would be nitrogen. Now, if you want to try to identify this one, all you have to do, we're going to do the ones that I have still showing. All you have to do is look for your nuclear particle. So we're going to do this one. Okay, that is my beta. So you always, I try to identify or name these. All you have to do is try to identify your nuclear particle. This would be the beta particle, and it is on the left. So if you remember your ABCs, you can say either absorb, bombard, or capture. So that would be a beta absorption, beta bombardment, or a beta capture, whichever way you want to go. On the right-hand side, or on the next one right here, if you look, you have a positron. So once again, positron. And if you look at where it's located on the equation, it's to the right of the equation. So what you want to do is figure out your D's or E's. Okay, so because it's on the right, you want decay or emit. So it's positron emission, positron decay. Once again, whichever way you want to go for this class is absolutely fine. So once again, to identify, you just identify what nuclear particle you're talking about, or is found in the equation, and then you identify what side of the equation that guy is on. Have a great night.